This is a video for AQA Discrete Mathematics, Critical Path Analysis, Section 2.1, Constructing a Gantt Chart. Well, you've seen in previous videos how we can construct an activity network firstly from a precedence table and then by doing what's called a forward path and a reverse path to work out the early times of an activity starting and the latest time it can finish. So for example in D we can see its early time is 2 and latest time it was finished 13. Once we've got the activity network, we can then find what's called the critical path, which is shown here in red. Now for D there's a float time, because if we take the late time 13 and take away the early time 2, that gives us a value 11, but the duration of the activity is only equal to 7, so 11 take away 7 gives us 4. So we've got 4 hour, or 4 whatever the units of time are, float time. However, if we look at activity K, do the same thing, the latest finish time 26 minus the early time 23, and then take away the duration, that's 0. So there's no float on that activity and it becomes part of what's called the critical path. The importance of the critical path is that those activities can't be delayed, or at least if they are delayed then the whole project will be delayed by the same amount. However, the other activities, what are called the non-critical activities, they can be moved around where they within their range of values. So as long as they aren't starting until their earlier start time and they're completed by the latest finishing time, then the actual activity itself can be put at a different position. So just a recap about the float time then. The float time is the latest finishing time minus the early start time minus the duration. And those with 0 float are called critical activities, and then the others are non-critical activities. There will always be a critical path from start to end of a project. So if we look at C here, this has got 8 minus 2 minus 6 is equal to 0. That's a critical activity. And as we said earlier, 13 minus 2 minus 7 is 4, the float time for D. Now the activity network is useful because it shows the critical path. However, it's quite difficult to read the float times and from the activity network. So another way of doing that and to illustrate the activities in relation to each other is something which is called a Gantt chart or cascade diagram. And what it does, it puts each activity onto a timeline showing where it must start and end and also its duration. So it's normal to put each of the activities at its earliest start time. However, sometimes you may be asked to put the activities at their latest finishing time. So what we would do here, for example, if we take D, then its earliest start time there is 2. So it would start here. It's got a duration of 7, which would take us up to, obviously, up to 9. So this would be D. Sometimes it's useful to put in the actual duration on there, 7, so we'd say D, duration 7, just as a check. But it must be finished by time 13, so the float time is then indicated by a dotted rectangle. So D can actually fit anywhere within the space from 2 up to 13. So the Gantt chart does the same thing for every single activity within the project. Now it's quite usual to start off with the critical activities. So A must start at time 0 and has got duration 2. So we fit that one in, and of course no float time, so no dotted rectangle after it. C can start at time 2 and has got a duration of 6, which would take us up to 8. And then E goes from 8 with a duration of 9, taking us up to 17, etc. So this shows the situation where we've put in all of the critical activities. So A, C, E, G, I, K and J. So following through the critical path. The rest of the diagram then looks at the non-critical activities. So if we go back here to B, we can see that that can start at time 2. So we come onto a new line for B, and it has duration 3, so there'll be a rectangle length 3 for B, and then it can go on as long as 8, so the float time is indicated by the rectangle continuing there up to time 8. D can also start at time 2. If you look at that one, it has a duration of 7. So taking that would take us up to 9. Sorry, that's D, beg your pardon. And has then got a float time of 4, as we discussed earlier. So then it'd be a dotted coming up to time 13. So that's D. Now it's quite difficult to do on this board, so if I just jump forward, you can see here we have all of the non-critical activities. So remember that what you're doing is you're taking a rectangle from the early start time and up to the latest finish time, and also indicating a solid rectangle which has got the duration in there. If you wish, you can write in the duration as a number. No harm in doing that. So for example, B duration 3. This then produces the full Gantt chart. Now the advantage of doing it this way is that we know that at the top here we've got the critical activities. So, and then we've got all of the non-critical activities placed below it. And once we've got this, we can then decide whether we need to make some changes to where the critical activities take place. So for example, if we look at F here, we could decide that we need to move it a little bit to make the project go smoothly. So for example, maybe there aren't any workers available at this time, but if we moved along into this position at the end, then the workers may become available. And that's the subject of the subsequent videos. We shall look at how we use the Gantt charts.